Another question that comes up in your trigonometry is how to find out the area of a triangle. When you did your junior cert, you would have been told of how you find the area of a triangle was your half your base by your perpendicular height. That is brilliant if you are asked to find the area of a right angle triangle because you have a perpendicular height. If it's not a right angle triangle though, you have to then be able to calculate that perpendicular height, so it can make it slightly difficult. The easier way to find the area of a triangle is you use the formula half AB sine C, and that is given in your log tables. What that translates into is you go half the length of a side times the length of a side times the sine of the angle in between them. So you can have a triangle. It doesn't have to be a right angle triangle, and you know the sides. So this would be A, so that will be A. This will be B, so that's B, that's C, and that's C. So if we wanted to work out the area of this triangle, we could go half AB sine C. So half the side times the sine of the angle in between. Or you could have done half AC sine B. Or you could have done half CB sine A. So again, this formula stands for half a side, sine the angle in between. So to use this formula, you need two sides and you need the angle in between them. So if we jump to the book, okay, this is page 404, Tests and Text. They ask you to find the area of different triangles, right? So in terms of your triangles, if you're going half your base by your perpendicular height, these are not right angle triangles, so there is no perpendicular height. For each of the triangles, though, you can see you've got a side, and the angle in between. So the area of this is simply half 8 times 10 sine 37. Same with this. Half of 4 times 5 sine 48. Half of 4 times 6 sine 72. Okay, and in majority of cases, it's not that easy. If we look at these ones, find the area of the triangle again, you don't have perpendicular height, but you have got two sides and the angle in between. So you go half 6.4, 7.8 sine of 28. This one, you have two sides, but you don't have the angle in between. So how you work out the angle in between is you know that a triangle has 180 degrees. So for this one, you would go 38 plus 48. So 38 and 48 give you 86. And then you'd go 180, take away 86, so you get 94. So you know that this angle here is 94, and then your area would be half of 11 times 9 sine 94. Okay, so to use your half AB sine C, you just have to make sure you have a side, sine of the angle in between. We're looking at this one again, very, very similar idea. They've just given us a different type of triangle. You have two sides, but you don't have the angle in between. So you have to calculate the angle in between. So how, again, you do that is you'd add the two angles they've given you. So 120 and 28 gives you 148. Take 148 away from 180, so you get 32. And then you go 23 times 14 sine of 32. Okay, if we jump over to the next page, slightly different. It says the area of the triangles is given. Find the measure of the angle. So again, your formula, you could go half the base by the perpendicular height. If it was a right angle triangle, these don't look like right angle triangles. There's no right angle symbols. So you'd be using your half AB sine C formula. So we have two sides, we have the angle in between. That's the bit that's missing. So you'd match it. So in terms of this, you'd go 29 is equal to 6 times 10 sine of x. We want the x on its own. So you'd have 29 is equal to 60 sine x. So your sine x is equal to 29 divided by 60. We want the x on its own. So x is equal to the sine inverse of 29 divided by 60. So make sure you plug that into your calculator correctly. You're not getting the sine of 29 and then dividing it by 60. So you get sine inverse, fraction button, 29, 60, move it over, close your bracket, equals, and we would get 28.9. So x in this case is equal to 28.9. You would do exactly the same for the next triangle. So in this case, again, we've got two sides. We're missing the angle in between, but we have the area. So you go 47 is equal to 18 times 14 sine of b, and then work it out as we've just done. For question 7, it says the area of the triangle shown is 30 square units. Find the length of the side marked x. So again, it is not a right angle triangle, so you can't use your half, your base by your perpendicular height, but you can use your area is equal to half side, sine of the angle in between. Right, or half AB sine C. So in terms of this, they have told us the area is 30, so you go 30 is equal to half 12 x sine, the angle in between is 37, right? So what I would do here, this half is going to mess with some of your heads. So imagine it's all written over 2. So on the top, you would have 12x sine 37. On the bottom, you've got 2. And on the far side of the equal sign, you've got your 30. If we want to get rid of this 2, you bring it up and you multiply. So you get 60 is equal to 12x sine 37. Okay, we want the x on its own. So to get the x on its own, it's currently being multiplied by 2 things. So we want to get rid of those 2 things. You can do it in steps, or you can do it together. If we do it in steps, you could have 60 divided by 12 is equal to x sine 37. So 60 divided by 12 is equal to 5. So you'd have 5 is equal to x sine 37. And then we want the x on its own. So we would have 5 divided by our sine of 37 equal to your x. So at that stage, you then get out the calculator and you go 5 divided by sine of 37, close your bracket, press equals, and you get 8.3. So x is equal to 8.308 for that one. Okay?